All right, how's everybody doing? It's cold outside, but it's warm in here, which is a really tacky opener, but only half of you were listening anyway, so that's okay. Got everybody's attention, so that's what works out. So we're here to, glad you're here tonight. What we wanted to do is really take a little look at what science can tell us about a creator, right? Not so much in the sense of we're going to prove the existence of God or look at all these cool things that science tells us and therefore this has to happen, but think more in the sense of, if you're listening to music or if you're looking at art or if you're reading an author's works, you learn about the author by reading what they've written. Right? You learn about an artist by looking at their art, and you can get a sense of who that person is, even though you don't see them. Right? And our premise tonight, and this is not the only premise you could have, but our premise tonight is that creation around us shows the handiwork of its creator. That as we look at the world around us, we see the character of the one who created it. And as a result of that, in order to learn about the world around us, we use the tools that we have available to us to understand how the world works. And so both Dr. Ridley and myself are really excited to be here. A little bit nervous. We're trying to figure out exactly where the tomatoes are coming from. No, just kidding. Just kidding. That was a joke. Everybody take a breath. We'll be good. All right. Now, what we want to do, I'm a professor of economics, so I'm a social scientist. That's my claim to be doing something on the science side. I know many of you are thinking social science isn't really science. That's exactly right. We do try to use fancy models and a lot of math and statistics to way more decimal places than we use. So it looks like we have some precision and get some street cred with the scientists around. Dr. Ridley is a real scientist, and so he'll be doing the real science stuff. I'll be doing the pseudo science or the soft science stuff as we go through. Ian Barber is a noted thinker about science and religion, suggested there are 4 different ways that science and religion can be related. We're really familiar with the first one, conflict. Right? In fact, probably a lot of times if you were to ask somebody about science and religion, what is going to come to mind is conflict. Right? And there are a couple of reasons for that. One is conflict gets clicks. Right? None of you have ever clicked on an item on social media that said, these 2 people are getting along really well. I mean, you don't care, right? You click on the stuff that says, see what tore apart the cast of your favorite TV show. That you're interested in, right? And so conflict kind of sells papers in an old vernacular. And there are instances where there is some real conflict, but as you dig into it, what you find is in most cases, there's not. Right? That, in fact, if you were to try to go around to most of the folks who work in science on campus here, you're not going to hear a lot of, you can either believe in a God or you can do science. Right? In fact, I would suggest that's a pretty, especially that stringent of you is pretty rare. Right? So what we're going to do mostly is we want to look at these second 2, dialogue and integration. Right? And in particular, what we're thinking of is how can we use the tools and methods that science gives us in order to, again, understand the nature of the creator. And science, as we think of it in an academic setting, if you think about what biologists do, what chemists do, what physicists do, I really want to throw in what economists do, but it just doesn't seem like it fits there that well. What they're doing is they're trying to understand the world around them. Right? They're trying to look and say, what is it that's beyond us, right? So when you look up in the star at night and you see stars and you ask, how does all that work? Or what lies out there that we can't see? That's really a question asking about how is the world formed? How does the world behave? What do we do with it? If you're working for a pharmaceutical company and you're trying to put together a way to treat a disease, you're relying on understanding how bodies work and how certain diseases function and how certain chemicals work to counteract that, right? And so at its core, science is basically asking the question, how do the things around us work? Right? And coming at it from a perspective of faith, we're looking at this and saying, well, we believe those things work well, and we believe we can understand how those things work because they're not random, right? That we're not in a universe that is just kind of going by chance. We're in a universe that's orderly, that allows us to understand how it works. And as we do those things, we can see the fingerprints of the Creator, and we can understand the character of the Creator. I've had this discussion with a few folks. As a person of faith, I take pretty seriously Jesus' statement in John 14:6 of, "I'm the way, the truth, and the life." And a lot of times, I remember the first time I read that, and it really hit me, because a lot of times we think of truth as this thing, right? We're going to pursue truth like we're pursuing this thing, and yet Jesus said, no, truth isn't really a thing. I'm the truth. And if he's right with that, and I'm going to go out on a limb and suggest he is, then as we pursue truth, we're going to encounter God. Because if Jesus is the way, the truth, and the life, and particularly that truth part, then pursuing truth is going to lead us to him. Right? Now, it's going to lead us to an encounter with him. It may cause us to reject him when we get there, but that's a whole different thing. We see in other places, in some of the great poetry of Psalms, some of the same idea that we're talking about tonight. The psalmist writes that the heavens declare the glory of God. The sky above proclaims his handiwork. And as you look up and you look in wonder, whether it's with your naked eye or with a telescope or with really, really cool telescopes that NASA puts in space, we're looking up and we're saying, this doesn't stand in opposition to the God of the universe. It stands there bearing testimony to what you can see and not see in all of this. Same thing in Psalm 139:14, the psalmist writes that he's fearfully and wonderfully made. And as we understand more about who we are as humans, again, we see the handiwork of a creator in there. From a philosophical perspective, this is sometimes called a teleological argument, basically derived from a Greek word meaning purpose, right? And kind of the argument would go, I don't really like the word argument. The approach would say something like this: when we see things that seem to have been designed, we believe that they've been designed for some purpose or some aim. Right? And so we also then look and say that a design in some way or shape points to a designer. And so we're looking and saying that nature around us points to its designer, points to its creator, and the tools of science and the disciplines of science can then help us to understand our creator by pointing out who he is and what it is that he's doing. This idea isn't really new. We've got a couple quotes from, some are much older than others. 45 BC, we have this: when you see a sundial or a water clock, you see that it tells the time by design and not by chance. How then can you imagine that the universe as a whole is devoid of purpose and intelligence when it embraces everything, including these artifacts themselves and their artificers? Cicero has this in the past, a little bit later on, or really a lot later on, but in the 17th century, Robert Boyle, the vastness, beauty, orderliness of the heavenly bodies, the excellent structure of animals and plants, and the other phenomena of nature justly induce an intelligent and unprejudiced observer to conclude a supremely powerful, just, and good author. And again, these are just pointing out the common theme that as we look at nature and as we see the gifts that nature has, as we see the order of nature, we look and say that there seems like there's something behind it, that randomness probably doesn't generate all of this that we see. Let me give you another example of this. How many of you watched the eclipse in August? That was pretty cool, all right? There were a lot of things that came to my mind as that was taking place, but one of them, as it relates here, is this: was anybody surprised that the eclipse happened? Anybody walk outside and say, "Wow, it seems like it's weird out here today. I don't know, something's like going on with the sun, and why are all these people gathered out in front of the science buildings?" Right? There's a nice article that I read that Hopkinsville, right, the point of greatest duration of eclipse, that was attracting people from all over the world to come and watch the eclipse there. They found out about it this way. Someone called them and said, "Hey, what y'all doing for the eclipse?" And they basically said, "When is that?" And the guy said, 12 years. You ever think about that? And in fact, some of you probably are even getting ready now for the eclipse in Carbondale in 2024. Right? You've got it marked on your calendar. Maybe you're making some hotel reservations. That the movement of the heavenly bodies is orderly and predictable, down to, and this is what really amazed me. At one point in time, I had a sheet of paper with me as we were looking at it, and it had down to the hour, minute, and second. And I'm sure that somewhere it had those seconds broken down even more as to when each part of the eclipse was going to take place. That's pretty cool, right? That we can understand the movement of the celestial bodies in such a way that we can say, at 11:59 and 12 seconds, this is going to take place. Right? Probably if I asked you, in addition to just enjoying the eclipse and thinking what a cool experience it was, you could probably tell me what caused a solar eclipse. So some of you, for instance, would tell me, because we know this, that solar eclipses are the result of giant frogs or dragons or wolves devouring the sun. You had that, right? If you have kids, or if you have little brothers and sisters, you were telling them when your science teacher asks what causes an eclipse, it's a dragon eating the sun. Right? That was going to work pretty well. We know that eclipses are bad omens for kings, right? So that if you were a king, maybe in Babylon, and it was, I don't know, first millennia BC, when you'd already kind of figured out how to predict eclipses, you would know that you want to get a substitute king for a few days, because something bad was going to happen to the king if an eclipse came. And I thought it was really clever that what they would do then is they'd get the real king out of town and put a fake king on the throne so the bad stuff could happen to the fake king. I like that. That was good. Many of you, and I think Dr. Cobb and the College of Science sort of handed some of these out, knew that if you banged pots and pans during an eclipse, it'll go away and the sun will come back. It's kind of, I think that's just kind of common knowledge. All of this is from timeanddate.com of beliefs about the eclipse through time. And when those beliefs were prevalent, that was the best explanation of what was going on with the sun in that time. And now we look back and say, well, it's kind of primitive because we understand some things a little better. Right? We understand some things about timing. We understand some things about cosmology, how the celestial bodies move around. And what we want to suggest is that this knowledge of the world gives us insight into the creator of the world. And that is, as we understand the marvels of the world, what it does is it reveals the marvels of the Creator to us. And the more we understand how uniquely tuned we are as humans, the more we understand that we can predict an eclipse with great certainty in time, the more that we can understand that we can shoot rockets into space with humans in them and bring them back safely and various things like that, that it points us to saying, this maybe isn't just here. And if it's not just here, maybe there's a purpose and an order behind it. And with that, we're going to move into some real science. So I'm going to turn it over to the actual real scientist for that.
Well, I am real, and I study physics and astronomy, so I guess that makes me a real scientist. But if we want to study creation and look at religion and science, we have to first look at what does science say about creation. And one of the biggest theories that we have about the creation of the whole entire universe is something called the Big Bang Theory. And this is just from NASA here. They've got this idea that a long time ago there was a massive explosion, everything expanded, and where we're at today was a result of that. So from science, we need to understand, where did this come from and why did we come up with this? Did we just randomly say we need to come up with some other idea for how this came about? And just a couple facts about the Big Bang Theory. The theory states that 13.8 billion years ago is when the universe was created. And we think it all started at a single point, and it exploded and expanded from there. So again, I want to go back and say, why do we think this? Because there's a lot of people in this room, on this stage, that have lots of different ideas of how the creation of the universe occurred. And so let's go way back to a famous person. He's got a telescope named after him in outer space right now, but this is Edwin Hubble. And what he did is he looked at a whole bunch of spots in the sky, a whole bunch of just clouds of gas. They call them nebulae. And as we were looking at these, we realized these were not just a whole bunch of spots in the sky. These weren't just extra stars up there. They were entire galaxies of stars way up there in the sky. And he would take pictures of them, and we'd find out more and more about them. And one of the things we realized is that these galaxies, because they are galaxies and not individual stars, our universe is a lot bigger than we thought it was. And so what do we do with that? The fact that he was able to take pictures and look at all these galaxies, we were able to find out that each of these galaxies that are millions and millions of light years away from us here on the Earth, most of them are doing the same thing. They are all moving away from us. They're moving further apart from each other. They're moving away from us. And so scientists would take that and say, what do we do with that data? We look at this galaxy, we look at that galaxy, and more often than not, these galaxies are getting further apart from each other and further away from us. And so from a science standpoint, how does that relate to a Big Bang? And let's go back. Up the top there, we've got all those nice little galaxies. They're pretty far apart, and they're getting further and further apart. But what happened 100 years ago or 1,000 years ago? If they're getting further apart, that means back in the past, what do we know about them? They had to be closer together. And a little bit before that, they had to be even closer together. And if you go back far enough in time, eventually everything was so close together, we call that a single point. And so that's kind of how the origin of the Big Bang came about. A big explosion, and that caused everything to push apart. So one thing I do want to caution is this is a Big Bang with a capital T, and that T is for theory. And in science, we've got theories and we've got laws, and we've got to explain what we see. And the fact that it is a theory and not a law means that, yeah, we could have some ideas that counteract it. We could have some things that go against it. We're probably not going to be able to prove this, but this is why we think our universe was created that way. So let's go back and see where this came from. We talk about religion, we talk about science. If you think back to Copernicus, as those of you in my astronomy class will find out in a few weeks, he did not want to publish his idea that the sun was at the center as opposed to the earth at the center until the day before he died, because it went against what the church said. And we found out later Copernicus was not 100% correct, but he was correct in some of the things that he was very scared about. So this idea of science versus religion goes way back, and there was a little bit of conflict back then as well. So we have this issue of what does religion say, what does science say, and this idea of the Big Bang actually came out of this Jesuit priest from a Catholic university. And this is George Lemaitre, and he came up with this idea called the Big Bang Theory. And so this kind of the secular idea of the Big Bang Theory actually has its roots in religion. And note down here at the bottom, this is actually 2 years before Hubble came up with his idea of the Hubble constant and the expansion of the universe. Lemaitre was able to do this and put this all together. So this is the expansion of the universe. This is kind of why we think the universe was created from a scientific standpoint. But with everything in science, you always have to question things. And so this is questioning the expansion of the universe. And this was just this past August, we have a physicist who published a paper in a peer-reviewed journal, and he came up with some other model that says we don't really need to have the Big Bang occur. It's possible that our universe came about from another way. And so his statement there is, I believe the Big Bang never happened. So my question is, who's right? Is mainstream science right? Is this particular physics professor correct? Do we ever know? And let me tell you that it's because of things like this. This is why I don't worship science, but I like science. And that is, it is always changing. And what we have today is good. What we have in 10 years is going to be good. What we have in 100 years is also going to be good. Think about medicine. Think about technology. We are constantly improving. It is constantly changing. So the fact that science always changes, well, sometimes we've got it good. Sometimes we don't have it quite right. And I'm going to turn it over to Dave here. And he's going to tell you, well, how much George Washington loved science.
We think that's an actual T-shirt found at Mount Vernon. On the left, we're not entirely sure on that. One of my favorite philosophy articles, I know you all have those, right? You kind of go through different articles, journals of different branches of science or thinking, and you rank articles and think this is one of my favorites. One of my favorite ones is called In Praise of Uncertainty, and it starts with this line: the first president was killed by settled science. And we hear a lot about settled science, mostly from politicians, not really a lot from scientists, because the idea is that science is never settled. Right? What the author of that article was referring to was George Washington came down with some chills, a fever, a sore throat, some various things like that. He called in a bunch of doctors, very good doctors, really well-trained for the time doctors. They brought some leeches around. They bled him of a lot of blood, because that's what you did in the early 19th century, because clearly blood was flowing through your body and it was doing bad things to you, carrying stuff around. So if we can get rid of the bad blood, we're in good shape, or, well, we're dead. All right? And that is what in fact killed George Washington. It wasn't that they were poor doctors. They were using the best medical knowledge that they had at the time. And if you went into your doctor today and said, you know, I've got a fever, I've got some chills, my throat hurts, I'm coughing a lot, you know, could you take some blood from me? They're probably going to do something a little different, because we know more things now, we know different things now than we knew at that particular time. And this, I think, is one of the public perception differences about science and a scientific method. And it's that really knowledge proceeds in fits and starts. We know a lot more than we knew 50 years ago. We know a lot less than we'll know in 50 years. And when we think about science, we're not really thinking about a body of truth per se. We're thinking about a way of understanding the world around us. And so there's a thought process of a scientific method that we could look at. And really, it's kind of it's kind of what was described with the Big Bang Theory, right? We observe things, right? Maybe we observe that celestial bodies seem to be moving apart. Maybe we observe that in current issues, maybe we observe that a lot of people who played football seem to have a particular brain disease when they're dying. We observe certain things that are happening, and then we try to say, well, what's an interesting question that we can come up with from that? Or what's a way we can frame this question to understand what's going on? We're going to come up with something that we can test, a hypothesis or a prediction that says, if we're understanding the world correctly, then we should see these things. And then we gather some data and we test that. Right? And then typically we find whether it works well, where it doesn't work, we revise and start over again. So let me give you an example. In microeconomics, which is really where most of my teaching interest lies, we believe in it, or we model, we try to describe how humans make decisions in very particular ways. And let me just walk you through that in a kind of a simple example. So this is a slice of pizza. If I wander over to Matt B's Pizza on Main Street for lunch, and really I do that a lot, and I'm thinking through this in the way that we model people's decision making, I'm going to walk in and I'm going to say, well, what's the price of a slice of pizza? And they're going to say it's $2.95. I say, okay. And I'll think for a moment and I'll say, how much money am I willing to pay for a slice of pizza right now, given how hungry I am, given the time of day it is, all sorts of circumstances? And if I'm willing to pay more than $2.95, I buy a slice of pizza, I go sit down and I eat the slice of pizza. And then I think, well, I'm still kind of hungry a little bit, and so I go back up to the counter and I say, how much is a slice of pizza? And they say, it's $2.95, kind of same as it was a few minutes ago. And I say, okay. And so I evaluate and I think, well, am I willing to pay $2.95 for the second slice of pizza? And if I am, I buy the pizza, I eat it, and I kind of keep doing this process until I get to a point where I say, I'm not willing to pay $2.95 for a slice of pizza, and I leave. Okay? That's how we think about how humans make decisions in kind of a step-by-step, is the benefits of this decision greater than the cost of this decision way. Right? I'm going to let you in on a little secret. I have never thought about that when I've gone in to order pizza. Right? I don't actually go into stores and say, I'd like an orange. I'd like a second orange. I'd like a third orange. Right? I go and I say, I'd like to buy this. Right? So you could look and say, well, your model's not really that good because it doesn't really accurately describe the way actual human beings make decisions. Or you could look and say, you know, even though we might not make our pizza buying decisions in exactly that way, that model gives us some pretty testable hypotheses and forecasts. Right? And when I observe the decisions that people make, that model does a pretty good job of forecasting what's going to happen. Right? And so even though it doesn't exactly mimic the thought process you go through, it lets me look back and say, here's what's likely to happen if they lower the price of pizza. Or it lets me go in and say, you know what might work is if you did, if you wanted to sell more pizza, maybe pizza $2.95 a slice, or I don't know, 3 slices for $7. Right? It's a way of lowering the price of just the third slice of pizza. And so a good scientific model, or a good way of trying to understand the universe or understand a particular problem, isn't one that necessarily has all of the details correct. It's the one that lets us make good predictions and lets us test that model and revise it. Another way of putting that is Francis Collins, who was the head of the National Institutes of Health, wrote the book The Language of God. He says it this way. He says, in science, a good model does this. If we can see steps A, B, and D, a good model lets us figure out step C and forecast step E. Right? It's the model that lets us fill in the blanks well, and then lets us make predictions as we go forward. Right? And some of that even sounds probably a little more than what you wanted to hear on a Monday night. Right? But we understand that in a lot of ways. Right? So some of you have probably heard the concern that we're using so much antibiotic soap and using so many antibiotics in fighting diseases that we're about to run into some problems of drug-resistant bacteria. Right? And that probably came about as we were looking and saying, well, we're noticing that our drugs maybe aren't as effective as they could be. How do we kind of figure out what's going on here? Well, we're using a lot of antibiotics in this way, and this way, and this way. And some of you even probably look and say, well, it's actually pretty simple. What took place was we're killing all of the antibiotics that are subject to those, or killing all the bacteria that are subject to those antibiotics, and we're left with the ones that are resistant to it. And so the only bacteria that gets to reproduce, that gets to continue on, is the antibiotic-resistant bacteria, and this is where we have our problems. Be right. That's a pretty nice, kind of simple scientific method. Right? It actually kind of mimics in some ways what the idea of natural selection does, right? Of looking and saying that those organisms that get to reproduce and continue their gene legacy on are those that are adept at surviving in whatever circumstance they're in. Right? And those that aren't adept in surviving in whatever circumstance they're in, they kind of die off. Right? And if you start thinking about this, in some ways, a lot of the pictures of science that we have that are maybe not as correct as we would like fall into that category, right? So if I was on a ship and I went to an island and I noticed that all of the animals on that particular island really seemed like they were attuned for the living conditions on that island, and I noticed that there were other types of similar animals in other places that had different characteristics, I'm making an observation. And then I'm going to start trying to figure out how that observation works. And I might even write it in a book. And if I'm lucky, somewhere on the other side of the world, there's someone who's playing with garden plants, figuring out how genetics works. Right? And we start looking and saying, so we've got this idea that organisms in a particular environment seem like they're well attuned to that. And over here we have this idea that says, the way characteristics go through gene pools works this way, and we start putting all that together and we start thinking, we kind of understand a little bit more about perhaps how the world is working and what we might do in place of that. Right? And we're not looking at those things and saying, well, this is the last word, because a lot has changed since the 1860s. Right? But if we have a model that does a really good job of filling in step C and then allowing us to forecast step E, we've got something that's pretty useful. Keeping this back in the economics context, because that's where I live, I was listening to the Freakonomics radio podcast. I know a lot of you do that on a regular basis, and they were talking about celiac disease. And you're thinking, man, this is really getting good on a Monday night. Economics and celiac disease. What could be better than this, right? And what was interesting about that is how they went through the progression of observation and trying to figure out what was causing this. And then they came up with some really interesting a really interesting tidbit that kind of points this out. The group that has the highest rate of celiac disease is a northern African tribe, the Berbers. About 6% of Berbers carry the gene for celiac disease, which is phenomenally more than what is found anywhere else. Right? And it was never a problem, which is why so many of them had the gene. Because in order to suffer from celiac disease, what medicine is telling us is you need to have the genetic disposition and you need to be exposed to gluten. And apparently, if you eat a lot of camel meat and drink a lot of camel milk and live in the North African desert, wheat is not one of your staple foods. And so you never have to worry about celiac disease because you've got the gene, but it's not activated by gluten. Right? And so if you've got this gene, it can get passed on because there's nothing that's stopping it. Well, as a result of some warfare, the Berbers found themselves somewhat in a refugee type of status, and the World Health Organization and some other groups said, what can we do to help them? They need food. Right? And they need food that's easy to get to them, that's not going to spoil, that will provide these certain basic needs. And the easiest thing to do was to give them wheat. Anybody want to guess what happened? You get a whole bunch of celiac disease when wheat is introduced with that. Right? And as you start looking at that, you start thinking, well, how did this population get such a high genetic disposition without it ever causing a problem? Because they never had gluten. And so those who were affected never got sick, which meant they were able to continue to reproduce, and that gene pool continued to carry on. Right? And if, as doctors look back and examined this more, you start thinking, oh, I kind of see what's happening here, right? That before we really understood celiac disease, if wheat was a big part of your diet and you had the gene that made you susceptible to that, you pretty much got sick and died as a child. And then you didn't reproduce, that gene pool didn't continue on, and the incidence of that particular gene would decrease in that population. Right? And I remember I was thinking about this just before the guy on the radio said it, and it made me feel kind of smart as I was driving. And the guy said, so that sort of sounds like natural selection. And the doctor said, that's exactly what it is. You have this gene that is either carried on or not carried on based upon what's going on around it. And again, this is not necessarily saying they figured out celiac disease. It's not necessarily saying we actually know everything that we need to know about how different fields of science works. It's saying, as we've been able to observe, and as we've been able to make hypotheses that we can test, we're able to go back and we're able to look and say, here's how we can improve our understanding. And if we're right, or if this model is working, then we should see these things happen. Right? And that's one of the key aspects of a scientific model, being able to say, if this is describing reality well, then we should be able to see these things happen as we go forward. Right? And so, in many ways, we do science a bunch, right? Because we do a lot of things where we're seeking to observe the world around us, put it in some kind of a system that we can understand, and then be able to look and say, if this is right, what should we see from there?
So from the miracle of life and genetics and biology, we move on to the miracle of mathematics. And who in here doesn't love a little good mathematics? Okay, yeah. But 2 + 2 = 4. Whether you're English speaker, whether you're Roman, whether you're Chinese, whether it's ancient history or in the future, math is going to be math. And if you look at some of the ancient geometry that we've dealt with, some of the ancient anything that comes on this math background, one of the things we're going to realize is the miracle of math. It is a wonderful gift that we have that from language to language, there's not a barrier when it comes to numbers and math. And so the fact that we have this to be the basis of the foundation of physics, it just makes our universe that much more special for us. And so I want to go from math into whatever this is, which would be some of the laws of physics. And again, as you stare at that, you might say it looks all Greek to me, and well, you'd be partially right because, yeah, there is a pi down there, and there's a little mu there, and there's some other things here that are Greek letters. But one of the things I want to point out here is we have an expression or an equation to explain everything in our universe, whether it's electrodynamics or statistical mechanics or quantum mechanics or general relativity or anything in our universe. Whether or not we understand these equations, we have these equations. So how great is our universe? How simple and orderly is our universe if we have equations that can explain all these things that go on a day-to-day basis? Take it one step further, and some of you in my physics class are going to be very excited to have this table on your next exam because it gives you all these numbers and constants and things that you need to memorize. And I don't want to do any memorization here tonight, but I want you to show you all these numbers that do exist. And they will always be like this. So for example, if you have the mass of a proton or the mass of a neutron or the mass of an electron, they're not going to change. They're the same today. They're going to be the same tomorrow. They're the same from last year. They just don't change. And if they did change, just a small, tiny change in any one of those different constants, our world would be completely different. Our universe would be completely different. Just think for a moment, if water wasn't water, or if gravity wasn't gravity, what would our Earth look like? What would our solar system look like? What would our whole entire universe if any of those fundamental constants were different? And so what I want to go through are a couple different requirements that we need in order to have life. We have life. We've got a special Earth we live on. We've got a special place in the universe that we're at. But in general, what do you need in order to live? And so one of the things you kind of need is order. And we've already talked about this. And we looked at how nice and orderly the laws of physics are. We've got the miracle of mathematics. There's nice and order there. If you go to my office, you're going to realize I would get a lot more work done if it was just a little bit neater and a little more order in there. And so we know that we need order as opposed to chaos. We also need chemical diversity, elemental diversity. If you had a world full of just hydrogen, what would you get in a world full of hydrogen? Nothing but hydrogen. If you look at our world today, we need hydrogen, of course, but we need every other type of element so we can build and get these nice things, these nice living creatures. We need that. And again, if the universe started with hydrogen, we need stars to turn that hydrogen into helium, and turn that helium into carbon, and to nitrogen, and into oxygen. And we need those stars to explode to give us all those other elements that we get to build the planets and the people on the planets, which is us here on the Earth. Keep going, we need predictability in these chemical reactions. If you take 2 hydrogen and combine it with 1 oxygen, what should you get? That's H2O, that's water. What if you took 2 hydrogen and 1 oxygen and you put it together and you did not get water? That would lead to a very, very bad situation. So we need to have this predictability that when we take these things and we put them together, we know what the end result is going to be. And we also need something to connect everything together. And that very, very special atom, for those of you who have taken chemistry, those of you who haven't taken chemistry, you will see this in your chemistry class, but carbon is that really, really special element. It kind of holds things together. We're all made of carbon. Every living thing is made of carbon. Carbon is a very, very special thing that we need in order to have life. So let's go a little bit further. And for those of you in my astronomy class, towards the end of the semester, I'm going to ask you, what do you need in order to live? And the answer can't be your iPhone or Facebook or anything like that. The answer is going to be, well, you need some sort of universal solvent. In our case here, it's water. We need H2O. We need something to drink. We know what our body's mostly made of. We need that water. And fortunately here on the Earth, we have that. We also need a stable source of energy. You need to be able to eat things. The plants need to have nutrients. We need to get our energy from somewhere. And then finally, we've got to have a way to transport energy. We've got our nice sun. Our sun's going to take energy and beam it towards us. And so that's how our plants grow. We eat plants. We eat things that eat plants. And because we have a nutrient source, because we have a way to transport energy, those 3 things are 3 fundamental things that we need to live. And fortunately for us, we have those. Now we move on and say, what else do you need? And there's a whole bunch of things that we need. And as we go through these, we're going to realize that we are very, very special. The things that have to be just right are just right for us to exist here on the Earth. And I'll pause and go forward real quick to this really long list here, and I don't want you to read everything, but I'm going to go through a couple of these because some of these are very physics related, some of them are very astronomy related. I want to point to a couple really, really important ones that make us very, very special here on the Earth. And that first one is going to be our location in the galaxy. There's the center of our galaxy. Here's our nice spiral arms, and we have a whole bunch of stars. There's billions and billions of stars in our galaxy. And the sun, as you can see, is right there. Is that a good place to be? Is it a bad place to be? I think it's a good place to be for a couple reasons. Number one, if we are inside this green ring, anyone know what's at the center of our galaxy? It's a black hole. How big of a black hole? It's a supermassive black hole. Incredibly large. A lot of mass, a lot of gravity. So what do you think's happening very close to the center of our galaxy? There's a lot of gravity going on there. There are a lot of stars being pulled closer and closer to that black hole. And if you were a planet going around one of those stars, going around a black hole, how do you think you'd feel? Probably not too good. The other thing you have going on there is if you look at how bright that is, it's bright because there's a lot of stars there. And if you've got a lot of stars, you're going to have a lot of radiation. Why is our sun bad? Well, it gives us sunburn. And if we go out in outer space, it gives us some radiation poisoning. And if you have more stars, what are you going to get more of? More sunburn, more radiation. So when you're in an area with a lot of stars, you're going to have a lot of radiation, you're going to have a lot of sunburn. So we don't want to be inside that green ring. What about outside the green ring? You're not going to get a lot of sunburns out there. You're not going to have a lot of intense stellar radiation out there, but you also have very few neighbors. And if you don't have a lot of neighbors, what I said earlier was you need stars to generate those heavier elements that we use to build our planets. And so if you are outside that green ring, you don't have enough stars to generate enough heavy elements to build your planets. So the best place to be is going to be somewhere in that green ring. And fortunately for us, the sun is in the middle of that green ring. So that's good for us. Again, there's other planets that are there, other stars that are there as well, but we are in a good place in our galaxy. Let's zoom in a little bit and look at our solar system. There's our sun right at the middle, and again we have another imaginary green ring there, and these little circles represent the orbits of some of our inner planets. And so we've got Mercury, Venus, Earth, and Mars there. And one of the things you're going to notice is that Mercury and Venus are inside this green ring. This is called the habitable zone of our solar system, and it has something to do with water. We said earlier that you need water, and we need that water to be liquid. Ice is good to make things cold. Water vapor is good on a hot day. Well, sometimes you get it on a hot day. But generally speaking, we need our water to be liquid. And so our sun is a big bonfire out there. And what happens when you get too close to the bonfire? What's going to happen to your water? It's going to turn into water vapor and go away. So how much water do you think is on Mercury? Probably very little. So Mercury and Venus are inside this green ring. They don't have liquid water. So let's go outside the green ring. We don't have Jupiter and Saturn on here, but they are outside that green ring. What do you think would happen to any water that is on Jupiter or Saturn if it is now too far away from our heat source? It would turn to ice. And can we use ice? What if all the water in your body turned to ice? We would not be able to live. So we've got this green ring, which is the habitable zone. That's the area in our solar system where water could possibly exist in liquid form. And so if you look at it, the Earth is right there in that green ring. That's good. What else is also in that green ring? Mars. And so that's why we have spent so much time trying to go look at Mars and see, hey, is there life on Mars? Do aliens come from Mars? Did there used to be water on Mars? And that's because it is right in that green ring, that habitable zone here on the Earth. If you go a little bit further, there are a couple other things that need to be kind of just right for us to have life as we know it. One of those things is the rotation period. That's how long it takes us to go around once. As the Earth spins, it takes a certain amount of time for us to see the sun rise and see the sun set. And we know that that's about 1 day or 24 hours. But what this says here is, what would happen if that speed was faster? Or what would happen if that speed was slower? Let's look at the moon, let's look at Mercury, and let's look at Venus. All three of those objects have speeds that are very, very slow. It takes them days and days and days to spin around once. And so one of the things you'd notice is if you had a very, very slow rotation, the temperature difference would be too great. How many of you know that Mercury can get down to negative 200 degrees Fahrenheit? It's kind of surprising. Why is that surprising? That is the closest planet to our sun. We would expect something that is really, really close to our sun to be really hot. And yes, Mercury can get really hot, but because it spins so slowly, it also gets incredibly cold. And so our temperature difference from day to night gets really hot and really cold. And it would make it really, really hard to live on a planet like that. Here on the Earth, it can get to 60 during the day and then down to 30 at night. And we can deal with those types of temperature differences. But when you're on a planet with 300 and 400 and 500 degree temperature differences just from day to night, that's really, really hard to live with. Now let's look at the opposite case. What if instead of spinning around once every 24 hours, we started spinning around faster and faster and faster, and it took us 10 hours to have a day? That's kind of like Jupiter and Saturn. Those planets spin around so fast that their atmosphere winds get up to hurricane speed all day long. So what would it be like if you were in a hurricane? Well, if you're hunkered down, you could survive it for a little bit, but what if it was hurricane all day, all night, all year? So the fact that we have a just right atmospheric wind speed, or atmospheric rotation, planetary rotation, we are in a really, really good place to have life as we know it. And so putting all these things together, look at the tilt of our axis, look at where we're at, all those things are necessary for us to have life here on the Earth. And if you look at one of those by itself, it's not that terribly hard to go find another planet somewhere in our universe that is tilted the same way as us, or to find a planet that's the same size as us, or to find a planet that is the same this as us here on the Earth. But when you start trying to put all those things together, it makes it very, very hard or very, very unusual to find something like that. So the example we have here with the dice, if I gave you all 2 of these and said roll them, is it possible that some of you could roll a double 6? Is it possible? Yeah. And I would say, all right, if you rolled a double 6, stand up. And there'd be a few of you that stood up. And then I said, all right, those of you that rolled the double 6, roll it again and see if you get another double 6. And is it possible for some of you that stood up the first time to roll another double 6? And possible, but not as likely as the first time someone rolling a double 6. And now we said, what if you rolled double 6 again and again and again and again, over and over and over and over again? Is that possible? Yes, it's possible, but it's less and less likely. So if you look at all the things that we have here on the Earth going for us, there's a lot of good things there, but there's also a very, very low probability that all these things line up and are just right for us here on the Earth. One thing I'll do to relate this to this week. On Wednesday, you've probably heard of the super blue blood moon going on. Well, it's not really super, it's not really blue, it's kind of related to blood, but all 3 of these things are things that are happening to our moon, and each one by themselves is kind of unique. So there's a supermoon. The moon's going to be a little bit closer than it is at other times of the month, and so we call that a supermoon. It's also known as a blue moon. Every single month we have a full moon, but occasionally there's a month that has 2 full moons in it. So if you think about January 1st was a full moon. January 31st is another full moon. So we have 2 full moons in January. So that second one is called a blue moon. You hear the term once in a blue moon because that doesn't happen very often. Usually every 2 or 3 years, we are fortunate that both January and March this year are going to have a blue moon. So it does happen, but it's not terribly common, not terribly rare either. But you also have a blood moon. And when the conditions are just right for the Earth to block off the sun's shadow, to block off the sunlight, our moon will get blocked off and eventually turn red, which eclipses are kind of rare, but they are predictable and they're not terribly uncommon either. But what makes Wednesday morning very unique is you've got a supermoon, and you've got a blue moon, and you've got a blood moon, the eclipse, all occurring at the exact same time. And to my knowledge, the last time this occurred in our area was the middle of the 1800s, maybe 1850, 1860. So what's happening on Wednesday is a series of events that aren't terribly rare themselves, but when you line them all up together, that makes it a once-in-a-lifetime kind of event. So the one thing I have not yet talked about in terms of all this science is how does that relate to the Bible? And let's go look at the first chapter of Genesis. If you want to talk about creation and look at what science says, and then look at what religion says, let's go to the Bible. And chapter 1 lists all these things that God did in his creation story. And if you look at one of the things he was able to create was a flat earth. And actually, no, he wasn't. But if you look at Kyrie Irving, who is a very good basketball player, he made the comment that the earth is flat. And if you look back at these pictures, there's a flat earth. And back in history, people kind of did believe that the earth was flat. And if you got too close to the edge, what's going to happen? You're going to fall off. And so at one point, science said, yeah, that's our theory. We don't want you to go around, we don't want you to sail around the earth because you might get to that edge and you might fall off. And as science progressed, we realized, there's some things we can do. We can look at the Earth's shadow on the moon. We can look at some of these angles over here. We can find out that the Earth actually is round. And so science progressed, and science said that the Earth is round. But then we get back to modern times, and Kyrie Irving says, no, I think it's flat. Now, there's some things I would take some advice from Kyrie Irving, like how to dribble a basketball, how to shoot a basketball. But telling me that the Earth is flat, I'm not sure that I would take my scientific advice from him. So, what does the Bible say? Science says that, no, the Earth is not flat. The Earth is round. What does the Bible say about the Earth? Again, this is before Kyrie Irving's time, but the Bible says the Earth was a sphere floating in space. He stretched out to the north and hung over empty space the Earth. It was hung on nothing. So we've got a spherical object, not a flat object. And so when science used to say the Earth was flat, the Bible said it was spherical. And as time goes on, science kind of caught up and said, yeah, I think the Earth really is round. There's a whole bunch of examples we could do with this, but I'm an astronomer, so I like stars. And when you go outside at night, you see all those little specks of light. And most of them are stars. A lot of them are stars. And back in the day, science said we've got about 6,000 stars that we can see out there. That's a lot of stars. And again, if you think back in the olden days, we didn't have Facebook, we didn't have the internet, we didn't really even have electricity. And so when it got dark out, you went outside and you had to look at the stars. There really wasn't much else you could do. And so they were very good at counting the stars and knowing where all the stars were. Now the problem is the Bible says that the host of heaven cannot be numbered, or there's an infinite number of stars out there. And at that point, that kind of clashes with what science says, because science says, no, I go outside and I count a few thousand stars. And there's a difference between a few thousand and cannot be numbered, or infinity. And so at the point, in the 1600s, we had this thing called a telescope. And we take that telescope, we point it toward the sky, and that one little speck of light, that little star up there, found out it wasn't a star. It was an entire galaxy filled with billions of stars. And we did this over and over, and science finally got to the point where, you know what? There really are billions and billions of stars up there. So again, what does the Bible say? What does science say? It looks like they're starting to match up, at least in a couple of these cases. And then one final case that I will have is what happens on day 8. We go back to Genesis again, and it says, on day 8, all the males should be circumcised. And so first off, why would you say that to anybody if you didn't have to do that? And second off, why day 8? You could have picked any day, your first birthday, your 18th birthday, your 21st birthday, after 1 month, on the first day, the day that you're born, the second day, because you're done crying then. No, you're never done crying, but why day 8? Were there medical experts back in Genesis? Well, for their time, there were people that knew what they were doing, but as far as this is concerned, it wasn't until 1984 where medicine and technology realized there's this little bit of a dip in this substance called prothrombin. It's something that's created by your body, and it helps blood to clot. And so you can see that right after you're born, the amount of that substance goes way down. And so that's this first week of a baby's life is very, very critical, because blood is not able to clot very well because that substance goes way down. But if you look, that substance, the amount of it goes way up and actually goes above 100%. So a baby has more of this stuff than a normal person on day 8. So if you're going to do a procedure that's going to involve some sort of bleeding for a young child, you want to do it at a time when the blood's able to clot and the bleeding can stop. And so it's amazing that that happened on day 8. And you go back a couple thousand years, few thousand years, the Bible says do this on day 8. And science says, well, the best day to do this is day 8. And so because of that, there's a lot of things we can look at in science, a lot of things that we can look at in the Bible and with religion, and we can slowly see these things start to come together. They are not mutually exclusive. So to finish up, where do we go from here, and what do we get out of this? And so I think Dave is going to come finish up and say, what do we make of all this?
I was really hoping for a Yoda quote. I like talking Yoda-like, but it only works well if there's a quote. So kind of to think about this, one of the things that we hope that you're getting out of tonight's hour together is this, that science and faith aren't in conflict with each other. Right? I'll give you this as a personal story. Some of y'all maybe have sung the song, "He's Got the Whole World in His Hands." Maybe you've sung it to a kid or something like that. And for a long time, because I get weird pictures in my head, it just happens, right? I sort of pictured, these two hands, sort of like Allstate, where you're in good hands, and they were kind of here like this, and there was a globe in them kind of filling them up. Sort of like if you take maybe a 10-year-old and ask them to put their hands out and you put a baseball or a softball in there, right? And they've got the whole, and maybe you've even done that and said, and this is how God holds the world. All right, so that makes, it didn't make sense to me, but it's the picture I had going on. And I don't remember where this was, but you've probably seen these animations that maybe say, here's Murray, Kentucky, and then it steps back a little bit, and here's Kentucky, and then it steps back a little bit, and here's the United States, and then it steps back a little bit, and here's the Earth, and it steps back, and here's our galaxy and our soul, and it just goes back and back and back, and you look for this little tiny, tiny speck, and that's kind of us, right? And it dawned on me one day that little "he's got the whole world in his hands" thing isn't about holding a baseball, a globe like a baseball in your hands. It's this uncountable multitude of stars. It's this galaxy, this universe, that each time we look into the heavens, we see there's more and more and more. And you start to look and say, sometimes I can get small coincidences, but I don't necessarily think that everything, as we learn more and more, as we learn more about order, as we learn more about how bodies function, as we learn more about the way the world around us works, that to me it doesn't seem like, it just happened, is a great explanation. There are 3 great philosophers in Toronto, Canada. The band Rush. I know it's an old reference for you. I really liked Rush growing up. They have an album and a song called Roll the Bones. It's a gambler's term for rolling dice. And it expresses in a lot of ways their very materialistic, very naturalist worldview that this is what we've got. In the chorus, it's uplifting. It's one of those that you want to get together with friends around a campfire and sing. I wrote it down here so that I could quote it to you accurately. Why are we here? Because we're here. Roll the bones. Why does it happen? Because it happens. Roll the bones. Am I feeling slightly more depressed than you were when I read that? Right? Does the thought that our existence, our planet, our universe is just, it's just this accident, and so are you, and things are going to happen to you for no reason except because they do, that's not really satisfying to us, right? We look in times of suffering and we hope that out of suffering comes something, right? We look at our legacy, right? Whether we're young or old, we look and say, I hope there's something that's a story that's bigger than me that continues on because, and I'll depress you with this again too, but I was born late in my parents' life. My parents were in their 40s when they had me. And I don't know my great-grandparents. I don't know them personally. They were long gone before I came around. I don't know their names. I could go to Ancestry.com and find them, but I don't know their names, right? My children's grandchildren, probably won't know really me, right? Or my name. Right? You can go around, there are a bunch of buildings that are named on this campus because we kind of look and say, we'd like to have kind of a legacy, right? Cleo Hester. Anybody live in Hester? No Hesterites here? All right. That's kind of good because I was going to put you on the spot if you didn't ask who Cleo Hester was. Right? Nobody knows. Right? Actually, former registrar at Murray State for a long time, but I only know that because Wikipedia told me, so I'm hoping it was right. We long for something that is more than just what we can experience. We hope that our existence isn't just kind of this cosmic accident and we're here for a short time and then we disappear. And as we look and we think, there's more to the world than we ever imagined. And in 50 years, when probably in actually the same theater, maybe even using that same laptop, this presentation is done again, the world will be far wider than anything we can dream of now. And we sort of hope that there's something more to it than just, you've got 70 years. Right? And as we look at the creation around us, it reminds us that there's a creator. Because it's really, really hard to look and say, all of these things just kind of happened. And if there's a creator, then maybe there's a purpose. And really what all of us want is to know that we fit into a purpose somewhere. And as we go through life, we start realizing that we have less and less control of what goes on around us than we think. And we hope that there is a storyteller, a writer, someone who is giving purpose to all of this that came before us and all of this that will come after it. And as we look at the universe around us and we start to think, it's possible that this happened by accident. It's also possible that Dr. Ridley gives you a pair of dice and you throw 614 pairs of sixes in a row. It's mathematically possible. But I'm telling you, if you were playing dice with somebody and they rolled, and it's not going to take 614, if they roll 6 pairs of sixes in a row, you're going to be asking to see those dice because you're going to look and say, this is so unlikely that I can't believe that this is actually happened. We don't see faith and science in conflict. We see science as a way of understanding the creation that God has brought us. Right? We see God using that to point to himself. Right? Let me think back with me. Some of you maybe grew up looking at newspapers, and in the corner of almost every newspaper somewhere, there's the horoscope section, right? And it's set up by the month of your birth, because a long time ago we sort of thought that where the stars were when you were born mattered, right? And maybe you even know some people who are still kind of into astrology, sort of looking and saying that the positions of the stars matter, or maybe you read back into ancient texts and you think, how could they worship the sun? I mean, we do it in a different way, but we have tanning beds now. How could they worship the sun? Well, they worship the sun because they recognize that we don't know what that thing is, but we know that when it's out, good things happen, and when it disappears for long periods of time, bad things happen. Right? And they tried to understand the world around them, and when they couldn't understand it, they started deifying the world around it. And imagine, if you will, that you're going into a land of people that look at the river as divine, because the river played a really important role in life. And they recognized that they needed rain, but they really didn't understand where rain came from. So they prayed and sacrificed to whatever god it was they could come up with that might bring rain. Or that they looked and said, for whatever reason, this animal may be more sacred than other animals, and we have to do something there. And imagine that you wanted to convey to those people that, you don't need to fear nature. You don't need to fear the sun. You don't need to worry about the river because it's not really your provision. And maybe what you might do is you might say to them, you see, all that stuff that you think is important, I made it. I created the sun. I hung it in space. I created the moon to give light to the night. I'm the one who controls the flows of the rivers, and the oceans stop where they do because I told them to. And here, let me tell you something else. I made you also. And I made you as my special piece of creation. and I called you to be my special people. And all of a sudden, when you go into an area and people say, we got to be careful. We haven't seen the sun in a while. We're going to have to do some sacrificing and some rites to make sure the sun comes back. You look and say, you know what? You don't have to do that because I know the God who created the sun. And I know the God who rules the sun. And I know the God who brings provision. And that perhaps what we are recognizing in some ways is the same thing that God was trying to tell his people thousands of years ago, that you don't need to fear nature because it doesn't rule over you. And you don't need to be worried about nature because it doesn't rule over you, because I created it. And I created you, and I called you. That's a much more fulfilling story, a much more fulfilling explanation than we're just here. I'm going to close by reading a couple paragraphs from a book from someone who's a lot smarter than I'll ever be. This is Timothy Keller's book, The Reason for God. He writes this. It's about 5 paragraphs long, but I'll read fast. It says this: when a Russian cosmonaut returned from space and reported that he had not found God, C.S. Lewis responded that this was like Hamlet going into the attic of his castle looking for Shakespeare. If there is a God, he wouldn't be another object in the universe that could be put in a lab and analyzed with empirical methods. He would relate to us the way a playwright relates to the characters in his play. We characters might be able to know quite a lot about the playwright, but only to the degree that the author chooses to put information about himself in the play. Therefore, in no case could we prove God's existence as if he were an object wholly within our universe, like oxygen and hydrogen or an island in the Pacific. Lewis gives us another metaphor for knowing the truth about God when he writes that he believes in God as I believe the sun has risen, not only because I see it, but because by it I see everything else. Imagine trying to look directly at the sun in order to learn about it. You can't do it. It will burn out your retinas, ruining your capacity to take it in. A far better way to learn about the existence, power, and quality of the sun is to look at the world it shows you, to recognize how it sustains everything you see and enables you to see it. Here then we have a way forward. We should not try to look into the sun, as it were, demanding irrefutable proofs for God. Instead, we should look at what the sun shows us. Which account of the world has the most explanatory power to make sense of what we see in the world and in ourselves? We have a sense that the world is not the way it ought to be. We have a sense that we are very flawed and yet very great. We have a longing for love and beauty that nothing in this world can fulfill. We have a deep need to know meaning and purpose. Which worldview best accounts for these things? Christians do not claim that their faith gives them omniscience or absolute knowledge of reality. Only God has that. But they believe that the Christian account of things, creation, fall, redemption, and restoration, makes the most sense of the world. I ask you to put on Christianity like a pair of spectacles and look at the world with it. See what power it has to explain what we know and see. If the God of the Bible exists, he is not a man in the attic, but the playwright. That means we won't be able to find him like we would find a passive object with the powers of empirical investigation. Rather, we must find the clues to his reality that he has written into the universe, including into us. That is why, if God exists, we would expect to find that he appeals to our rational faculties. If we were made in his image as rational, personal beings, there should be some resonance between his mind and ours. It also means that reason alone won't be enough. The playwright can only be known through personal revelation. That is why we have to take a look at what the Bible says about God and the human condition. In the Christian view, however, the ultimate evidence for the existence of God is Jesus Christ himself. If there is a God, we characters in his play have hope that he put some information about himself in the play. But Christians believe he did more than give us information. He wrote himself into the play as the main character in history when Jesus was born and rose from the dead. He is the one with whom we have to do. As we approach whatever parts of science it is we look at, as we approach how we understand human behavior, We don't approach it as something that looks and says, here's an alternate explanation. We approach it and we look and say, the heavens declare the glory of God, the sky proclaims his handiwork. And we see in all of this the architect of the creator. And we see in that if there's a creator with a purpose, then our lives have a purpose, that we're here for a reason, that our time on earth isn't just some accident of history, but it was here by the will and the design of the playwright who ultimately writes the story, and writes a story in which we can trust, because we can trust the one who wrote the ending to the story. We've kind of got a small group, so we were trying to figure out what we were going to do, like question-wise, right? Because really, we want to answer questions, but there's no good way to do this. I'm an economist. Everything is trade-offs, right? So we thought about doing you write on cards and hand the cards in, and then we'll read them so everybody knows what's going on. But that kind of takes some time and works really well in a big room. We thought about let's have a dialogue like this. But here's the thing. If Dr. Cobb asks a question, it's going to start in English when it comes from him, but by the time it gets to us, it's just some mumbled sound. So really none of us know what's going on. So with your permission, we'll stay as long as you want to be here. I know some of you may have places to go. Some of you may want to kind of cut out. But what do you think? We'll just hang around the front and we'll dialogue for as long as you want. I think like I said, we're not going to come up with the perfect solution in this, but with a crowd of this size, I think we can kind of gather around close, and if you want, we can, it's a lot easier to gather around close than it is to yell questions from the back or to do some various things. So that kind of concludes our formal part of this, but we're here, and we would love to talk with you. If tonight's not a good time, we're both on campus pretty much all the time. Yeah. I'm in the business building, 307A. Josh is in the new physics building, so he's got a cooler building than I do with that. But we'd love to talk with you. Thank you all for coming. Any closing?
That's good. Thank you.
Thanks.